Good morning, everybody, and welcome back. So last time we met, we introduced a method that does not require any equipment in order to start playing with coding. The method is called CodeIT and is basically a board game. I assume that you played with it during this week, so that right now you are prepared to start using your computers. So today you have computers so that you can follow step by step what I will show you. And the method that we are using today is a method which has been conceived and promoted by an international organization called code.org. So you can go to code.org in your own browsers on your laptop. So please go to this website, set the language to English, and press the hour of code, which is the tour that we will follow today together. So basically what I ask you today is to follow step by step what I do on the shared screen. And I will say something while doing these simple steps in order to illustrate which are the key concepts which are introduced at each level. But basically, you have just to play with the game that will be proposed at each level. So you can take it as a game because the concepts then are automatically provided while playing the game. So let's start with the first scheme, which is called the puzzle. And the entire tour that we will follow is composed of 20 schemes which are called puzzles, and the entire tour is called the labyrinth because it is always a matter of moving a character, which is the main character of the game, across a puzzle which looks like a labyrinth. So right now, the first character that we have to play with is Angry Bird, as you can see, and he has to catch the green pig. So this is his mission, and we need to help him by providing instructions to allow him to reach the pig and to catch it. Okay, so let's start. What you have to do here is to use the instructions, which are called the blocks, that you find here in this panel, to write a program which tells Angry Bird what to do to reach the pig. And the instructions have to be dragged and dropped into this panel here. And in order to be effective, they need to be put one after the other in this way. And you see that if you start a program in this way, if you press run, what happens is that nothing happens because we didn't attach the blocks to each other. So Angry Bird tells us to try again. So let's try again. And right now, we attach two move forward instructions, and we can reset, which means starting from the beginning, and press run again to see what happens. Okay, right now in just two steps, which were just move forward steps, Angry Bird reached the pig. So right now we are allowed to continue. So let's move to the second puzzle. It looks more or less like the previous one, apart from the fact that right now Angry Bird has to move from left to right. Notice that, however, Angry Bird is already turned towards the green pig. So even if it has to move on the screen in a different direction, because in the previous scheme, Angry Bird had to move vertically. Right now, it has to move horizontally. We keep providing always the same instruction, which is move forward. And this is the first thing that we have to notice, because we are taking the point of view of Angry Bird instead of ours. Because otherwise, we should tell him to move to the right, to our right. But instead, taking his point of view, we have to tell him to just move forward. And the other difference is that 2 steps are not sufficient this time, but we need 3 steps to reach the green pig. So the procedure to compose the program is always the same. We have to take instructions from here and to attach them one after the other. And notice that when we press run, this yellow highlight also shows us which is the instruction which is executed at any step. So let's try it. Okay, so we succeeded and we can move forward. Okay, this is just a little bit more complicated, just because the green pig is not exactly in front of Angry Bird. Angry Bird can start by moving forward because he is already turned in the proper direction, but at some point he has to turn to his right in order to reach the pig. So we have to tell him to move forward twice, then to turn at his right, and then to move forward again. And exactly as it happened with CodeIT, turn right and turn left do not change the square in which Angry Bird is at any specific time. So let's try, for instance, to do something like this and see what happens. Moves forward and then starts turning without changing the square in which he is. And needless to say, this is not a solution for this puzzle. So let's do it better. So first of all, we can get rid of this and this, which are useless. And we use another move forward. Then we turn right and we move forward again. So we are reset, which means moving Angry Bird back to the beginning, and then we press run. 2 steps forward, turn right, move forward. And that's it. Okay, let's go ahead. Yet another scheme in which we have to use just the 3 basic instructions, which are the same that you have played with during this week using the CodeIT cards. So right now I give you some time to solve the scheme by yourself. I think you don't need much time because I'm sure that you are already able to do it, and so I can already start doing my part. So taking the point of view of Angry Bird, I have to move forward, then I have to turn left, move forward again, turn right, and move forward. So move forward, turn left, move forward, turn right, and move forward. Okay, instead of moving forward, I want to repeat this scheme, so let me go back to the previous one. Or otherwise, no, we can, I can show you what I wanted to show in the previous scheme using this new scheme. So right now we have just something which is a little different from the previous schemes, which is the fact that we cannot start with move forward, or otherwise this is what happens. Okay, from move. From move just because at the beginning Angry Bird is not already turned in the right direction. So first of all, we need to tell him to turn to his right. Then he can move forward and turn left. And at this point, he has to turn to move forward, 1, 2, and 3 times. 1, 2, and 3 times. Then turn left and move forward again. I guess that this is the best solution to this scheme. But before going and testing this solution, I want to show you that I could do something different. For instance, this one. Which means that instead, at this point, instead of turning left, I could turn right, and turn right again, obtaining the same results, but using 3 instructions instead of 1. So let's see if it works. Yes, it does. Okay, notice, however, that we used more blocks than the ones which are strictly required. So this tool proposes to try again in order to do what? Just to optimize the code. This is something which is worth being discussed and appreciated. The fact that there is usually not just one solution to each problem, but there are many ways of reaching the same result. But among all possible solutions, some of them are more efficient and some others are less efficient. So right now, if I replace the 3 turn right with a turn left, I obtain a code segment which is shorter and that leads to the same result. So let's see if it works. And if it works, this is a piece of code which is more efficient than the previous one. Okay, here we are. So this time we obtained the same result using only 8 lines of code. And notice also that even if we are just playing with blocks, which look more or less like the CodeIT cards, each block is associated with an instruction, and this means that attaching blocks corresponds to writing a program in a specific language. And there are many languages in which these blocks could be translated, but in this case, this is translated in a specific language, which is JavaScript, and this is how it looks like. You see, turn right, move forward, turn left, move forward, move forward, move forward, turn left, and move forward again. Using a specific language means using a specific syntax, which is a language-specific syntax. And there are many programming languages. What is nice of this kind of tools, which are called visual programming tools, is that they do not require us to study the syntax of any language before starting writing code, because instead of writing the instructions, we can just compose the blocks on the screen. Okay, let's move forward. Right now, we have a new block which looks pretty different from the previous ones. And the difference is that this is a block that does nothing but allowing us to tell Angry Bird to repeat several times the instructions that we place inside the block. So let's first of all try to solve this scheme as we did before. As you can see, the green pig is right in front of Angry Bird, so Angry Bird has just to move forward 5 times. 2, 3, 4, and 5, and that's it. If we play this piece of code, it works properly. But we are challenged to try again using the new block. And the new block can be directly attached to the beginning of the program, and then we have to place something inside the block, and what we write inside the block will be repeated 5 times. So this means that this entire piece of code can be replaced by just one instruction inserted within this block, and we can get rid of the other instructions. Notice that this is kind of an optimization, but it doesn't change the complexity of the code. Even if we use just 2 blocks, the repeat block and the move forward block, however, this block inside the repeat has to be executed 5 times. So this means that the number of steps required by Angry Bird to reach the pig are exactly the same. So this piece of code is not more efficient than the previous one. This is just more structured, which means that it is much easier to understand and much faster to write. So let's reset and run it. 2, 3, 4, and 5. And here we are, ready to continue. Okay, again, we have just the 4 blocks that we had before, but the only difference right now, apart from the vertical path that we have to follow, is that Angry Bird is not turned in the right direction. So we cannot directly start with this block. Instead, we have to first tell Angry Bird to turn right, and then we can compose these instructions to tell him to move forward 1, 2, 3, 4, and 5 times. Okay? Notice also that we could do something different here, which is this one. Let's play with it and see what happens. Run. As you can see, Angry Bird turns left 3 times, and then he starts moving forward 5 times. Okay, so this is the result, but we used too many blocks. And if we do it this way, this is more efficient, and this is what code.org expects us to do. So let's see if it works. And here we are. Let's go ahead. Okay. Yet another scheme in which we have to use the repeat block. Let's look at it. So Angry Bird has to move forward 1, 2, 3, 4 times before having to turn to his left. So 4 times instead of 5, move forward inside the repeat block, and then we have to turn left. At this point, we have to tell Angry Bird to move forward again 1, 2, 3, 4, and 5 times. And this is what we need. Four times, turn left, 1, 2, 3, 4, and 5. Okay, we have to continue here. And let's read the hint provided by code.org. So when a block is gray, that means you can't delete it. Solve this puzzle using the repeat block that repeats 3 times. Try putting these 3 blocks inside the gray repeat block. Move, move, turn. Okay, let's try. So the difference is that we cannot get rid of this block. So the gray block has to be used as it is provided by code.org. So we have to figure out how to use this very first block and to put instruction just inside this block. And notice that we cannot just start this way, because if we tell Angry Bird to go ahead to move forward 3 times, you see, it will end up exiting or hitting the wall or exiting from the path. So we need to invent something different inside here. And what we have to tell him to do is, instead of doing just one instruction, one step like this, we need to do something different. And to this purpose, let me first put here all the instructions that we want Angry Bird to execute in sequence without using any repeat. So we want Angry Bird to go ahead and move forward twice, then turn right, move forward twice again, then turn right, and move forward twice again. Okay, so I could highlight that these 3 pieces of codes repeat 3 times, and they are exactly the same, apart from the fact that there is an instruction missing here. But I could add an instruction here, because this instruction will be executed once Angry Bird has already reached the pig. So it will not affect the result, because Angry Bird will reach the pig at this point. So let's see what happens if we have 3 pieces of code that are exactly the same and that have to be executed in sequence. What I can do is just to put these 3 instructions inside here and to get rid of the other ones. Okay, let's see what happens. Move forward, turn right. Move forward, turn right. Move forward, and here we are. Okay, this was exactly what they expected from us. Good, let's go ahead. Okay, now the puzzle is easier than the previous one, but the block is different. Right now, instead of specifying the number of times we want Angry Bird to repeat the instruction, we tell him to repeat the instruction as many times as needed. That means until he reaches the green pig. So if we place this instruction here, we do not have to count how many times he has to repeat the move. We have just to take care of which move to tell him to repeat, and he will check how many times he needs. to repeat it. So if I write, if I put a move forward instruction inside this block without specifying the number of repetition, and then I run the code, the effect is exactly the one that I wanted, that Angry Bird moves forward until he reaches the green pig. And there is the code. While not finished, move forward, which means repeat until you reach the end, and what you have to repeat is just an instruction which tells you to move forward. Okay, now we have the same 4 blocks and a puzzle which looks pretty much similar of the one that we solved at step 9, if I remember right. So this means that, once again, let me put here all the instructions that we need. So move forward, then turn left this time, and then move forward, and turn left again. And then once again, move forward, and turn left, which is not needed, but can be placed here just to make these 3 copies of the code segment exactly the same. And now I can just tell Angry Bird to repeat this path as many times as needed to reach the green pig. Okay, here we are. Can you please tell me using the chat if you are up to this point, or if you want me to stop and wait for you to complete the schemes that we have seen so far? Can I go ahead? Okay, great. Okay, let's change the main character. Right now we have a zombie, and the zombie wants to hit the sunflower. And the puzzle is much more complicated than the previous ones, because this time we need to zigzag a lot, you see. So I could tell the zombie to move forward and then turn left, then move forward and turn right. Let's see which is the effect of these first 4 instructions. Okay, so it seems that this is something pretty useful, but not sufficient to get to the sunflower that the zombie wants to hit. So I can take this and tell the zombie to repeat it as many times as needed, using exactly the same block that I used before, which is a repeat until block. Let's bring the zombie back and try to run the code. Okay, it worked properly. And here we are. Okay, ready to continue. This looks a little different, just because we don't want the zombie to take the wrong path, which is this one. So let's see what happens if we tell the zombie to move forward at first. Okay. So we have right now to avoid the chomper in order to bring the zombie to the sunflower. Let's try again and bring the zombie back. So the first move that we have to make now is a turn right. So once we have turned right, we are ready to repeat more or less the same move as before, which are move forward, then turn left, move forward, and turn right. Okay? So notice that I could do it this way, and let's see if it works. Yeah, it seems to work. But we are asked to try again just because we used too many instructions. In fact, notice that the first instruction here corresponds also to the last one that we placed inside the repeat until block. And if we keep repeating the block, I want just to show you what happens if we keep concatenating instructions like this. Instead of packing instruction in this way, I could split them in a different way, considering the turn right as part of the block of 4 instructions, obtaining exactly the same result. But if I put these 4 instructions directly inside the repeat until block, I save an instruction, which means that I write a code segment which is more compact. Okay? So this is shorter, and this is the way in which they want us to solve this puzzle. And here we are. Okay, ready to continue. Now there is a new block, which is a conditional block, which means that this time the zombie is asked to check for a condition in order to decide which move to take next. And there are a lot of gray blocks which are already in place and that we are asked to, to use. So let's try to understand what they do. Repeat until, and that's the block that we already used, then move forward, but then there is an if, which is a condition which has to be checked. And the condition is whether or not there is a path to the left. So here there are no paths to the left, here there are no paths to the left, here there are no paths to the left, here there is a path to the left. So we need just to add an instruction here to tell the zombie what to do if there is a path to the left. And what the zombie has to do is just to turn left in this case. And we don't need to tell him to also move forward, because this block here will be repeated forever until we reach the sunflower. So this means that move forward is already in place, because at each iteration, the zombie will move forward, check for a path to the left, and possibly turn left. But then this block is executed again, so move forward is already there, and since no other path to the left will be found, it will keep moving forward until he reaches the sunflower. Okay? You see, this is the symbol used to illustrate the fact that the zombie is checking for a path to his left at each step. Okay. Now we have to solve this scheme by using all the instructions that we encountered so far and without any initial hint. So we have to do it by ourselves. So I'd like to give you some time to find the solution, and I will start discussing it in a few seconds in order to allow you to think about it. So please do it yourself. Notice that it is dangerous for the zombie to take a path to the left, while it is necessary at some point to take path to the right. Okay, I think that you have already found a solution, so I try to do it myself. Repeat until, then move forward, and if there is a path to the right, then take a right turn. And that's it. Because this is exactly as the previous scheme, because each time we find a path to the right, we have to take it. And then we have just to move forward when there are no paths to the right. You see, this time, at each step, the zombie checks for paths to the right. And here we are. Now the character has changed again. Okay. Let's see what to do. So the instructions are exactly the same, and right now we have to turn left at this point, turn left, and turn left again. Repeat until, move forward, if path to the left, turn left. Okay, ready to test it. Great. First turn properly taken, second one again. Great. Please notice how compact is the code that we wrote. If we had to write instructions, different instructions at each step, we had to write how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24 instructions. Instead of 24 instructions, we use just 4 blocks, which are move forward, turn left, a repeat until, and a conditional block. Okay? This looks very similar. I think you are already putting together your own solution, so I can directly go and write mine. So repeat until, move forward if there is a path to the challenging here, because the block that we find here checks if there is a path to the left, but as you can see, we can select the different conditions to check. And in particular, in this case, we want to check if there is a path to the right and possibly turn right. Okay? So this is the only challenge that this scheme offers, meaning that we need also to think at which is the condition to check, instead of just taking the conditions that are proposed without thinking about them. Good. Let's continue. Okay, as you can see right now, a new block is introduced, which is not only a condition, but instead of having just a do part which tells what to do if the condition is true, there is also an else part which tells the character what to do if the condition was not. Okay, ready to try to use it. So right now, we have to put inside our repeat block this new block, which is composed of three parts. The first one is the condition to be checked. Okay, I give you some time to watch the video on your own computers instead of watching it on the shared screen. Okay, are you done? Okay, let me try to explain what we are doing now. So instead of using a block which was just a condition to be checked and something to be done in case the condition was true, now we have a decision to be taken between two alternative moves. The first one is a move forward, and the second one is turn left in this specific case. And the condition to be checked is whether or not there is a path ahead, which means whether or not there is a square in front of the main character. Okay? Now, what's nice here is that instead of checking the condition twice to take two different actions, the condition is checked only once. And if it is true, then the first move is taken. Otherwise, the second one is taken. So the condition is checked only once. Okay? Now, this is in my opinion at least, the proper solution of this scheme. And I want you to try to figure out is if this one is also a viable solution. So instead of checking for a path ahead and then move forward or otherwise turn left, I could check for a path to the left and then turn left or otherwise move forward. What do you think? Is it correct in your opinion? Could you please provide your answer on the chat? Okay. So the question is the second version correct? Okay, you say yes, let's try it. Get rid of this and run. Okay, here it works. Oh. You see what happened? That, let me reset it. So at this point, it found a path to the left, but it didn't move. Then it found again a path to the left, it turned, there were no more paths to the left, so it moved forward, and then it moved forward again, and it fell into the water. Okay, so it doesn't work. Let's try to make it work. So instead of just turning left and moving forward otherwise, we could tell him to move forward in any case right after having checked the condition. So the difference is that in the previous case, I check, the character checks if there is a path to the left. If there is, it just turns left without making any move. Right now, even if it turns left, then he moves forward. So let's see what happens. Uh-oh, too bad. It didn't work again. Why? Because he moved forward without having checked before the fact that there was a path to the left. So the first time he moved forward and then he moved forward again. So let's try it this way. Okay, it's working, but uh-oh, wrong way. So here we have another problem, the fact that not all the left turns are good. So in this case, we did not need to take the left path. So what was definitely better in the original solution was that instead of checking for a path to the left, which was not always a good path to take, we checked for a path ahead, which is always good. And whenever there are no paths ahead, there is always the same decision to be taken, which is turn left. Okay? So that's the reason why this piece of code is the correct solution and also the more compact solution, because it uses just a condition and two instructions. Okay, here we are. Almost done. Uh-oh. Let's try to figure out what to do now. So please think a little bit about it, and then we'll try to solve it together. It looks more complicated, but it is not indeed. So we can check if there is a path ahead, and when there is no path ahead, like this point, and then at this point, we have just to turn right, and that's it. So move forward or turn right. Great. Wow, this is the very last scheme that we have to solve. So let's see what happens here. The main difference of this puzzle with respect to the previous ones is that the path contains both right and left turns. So we cannot just check for a single condition and then take a decision between only two possible moves, which is move forward and turn either left or right. Right now, we have three different instructions to that need a decision to be taken at each step. So the block which provides just a condition and then a do and an else part allows us just to choose between two possible actions to be taken if the condition is or it is not verified. So this means that instead of just checking for a path ahead, we need first to check for a path ahead, and in this case, move forward. But if there are no paths ahead, then we have to look around and see which are the conditions in order to decide what to do. So instead of just placing a move here, which is either turn left or turn right, we place inside the else part of this condition another condition, which checks for a turn right, or better, for a path to the right, in order to decide whether to turn right or to turn left. Okay? So notice that in this way, we have three different actions and a decision tree, which allows us to choose which action to take. So if there is a path ahead, we move forward. When we arrive here, there are no paths ahead, and we check for a path to the right. Since there is a path to the right, we move to the right, then we keep moving forward. At this point, again, we have a path to the right, and we move here. At this point, we check for a path ahead, there are not. For a path to the right, there are not, and then we move to the left. Okay? So I take advantage of this last scheme to show you also that instructions, and in particular repeat instruction and conditional instructions, can be nested within each other. So inside the repeat until block, we already used the if statement. Inside the if statement, we are using another one. We could, for instance, use a repeat block inside an if statement, and then an if statement again, and so on. Okay, so there are no limits to the number of layers that we can add and to the number of nesting that we can make. So let's get rid of these useless instructions, which I use just to illustrate the nesting of instructions. And now let me put the turn left back in order to see if this piece of code solves this puzzle. No path ahead, but a path to the right. No path ahead, but a path to the right. No path ahead, no path to the right, but a path to the left. The same here. The same here. While here there is a path to the right, and we are done. Okay, that's it. And here is your certificate of completion. So what we did is called 1 hour of code, which is a complete path which allows us to familiarize with all the main principles of coding. So next time we will meet in order to start developing together mobile applications for Android. And what is nice is that we will end up developing a real-world Android application using blocks which looks exactly as the ones that we use today to play with 1 hour of code. Okay, so thank you very much for attending this meeting. I hope you enjoyed it. And also notice that you can play with it as many times as you want, because it is available online, as you have seen. So please keep working with it to familiarize with these kind of visual programming tools and also with the concepts behind it. Okay, thank you very much and see you next time.